Hello friends. So in last lecture we have seen about step up chopper, then combination of step up, step down choppers, then some control strategies. So today we are going to study these configurations in detail. Now if you remember in first lecture, while studying the chopper classification, we have studied class A chopper, class B chopper and so on, and also first quadrant chopper, second quadrant chopper, third quadrant chopper. So if you don't remember that, you can refer this diagram. So here E naught indicates output voltage, I naught indicates the output current. So first quadrant chopper in which both are positive, second quadrant chopper is output voltage is positive, then output current is negative. So basically, and so on, third and fourth. So first quadrant chopper, their application is for motoring, for example. In second quadrant chopper, their application is forward braking, for braking purpose. Second quadrant choppers are used. For third quadrant chopper, they are used for reverse drive, and fourth quadrant chopper are used for reverse braking. So one by one we are going to see all the chopper circuits in detail. So first we will begin with class A chopper, which is also called as step down chopper with RA load. This is a first quadrant chopper or class A chopper. Obviously, why it is called as first quadrant chopper, because it's, you can see this diagram, this is the output voltage, output current, both are positive in this case, and this is the diagram for first quadrant chopper. So this is very simple to understand. So when chopper is on, its output voltage E naught is equal to EDC. Okay, and current flows in a forward direction. When chopper is off, simply E naught is equal to 0. Its output voltage is equal to 0. Why it is 0? Though here inductor is there, but here we are having this freewheeling diode. Okay, so no output, no negative output current will be there. Simply your output current or output voltage is equal to 0. So this is the simple explanation given over here. You can read this. When the chopper is on, E naught is equal to EDC and current flows in the direction. When chopper is off, E naught is equal to 0. Why E naught is equal to output voltage is equal to 0? Because of the freewheeling diode DF. Okay, that's all. So um, this is the description of the working principle of first quadrant chopper, and this output voltage and output current, you can see here both are positive. That's why this is called as first quadrant chopper. Now girls, there is no need to study. If you want you can study all these things, but as per as your syllabus is concerned, because you are just in third year level, so these details are not expected, that it's steady state ripple and all this. Just the explanation which we have discussed is expected. So you can, if you want, you can skip this. As per as your final exam is concerned, you can skip all these points. But if you want to read, you can read all these points. Okay. Now, this example also not expected in the final exam. Now, directly we will switch to the next type. See here, lots of examples are given in this book. Okay, some examples are very easy to understand, so you can go for it. And if you have any doubt, please let me know. As these are the solved examples, we are not going to waste our time. So directly we are going to the second quadrant chopper or class B chopper. So basically this is also called as a step up chopper, and this is second quadrant chopper. Why it is called as second quadrant chopper? Because here output voltage, you can see this graph, output sorry, output voltage is positive and output current is negative. Now see how it works. So for simplicity, you can use this diagram also. So when chopper is on, okay. So friends, this is quadrant 2 chopper. So in this case, when chopper is on and chopper is off, if they are turning on and off on the regular basis, then the energy will get stored in the inductor whenever chopper is on, and the part of the stored energy is delivered to the source EDC by current through the diode D2. What I'm saying, when chopper is on or when it is conducting, a part of that stored energy is delivered to the source, back to the source ADC through the diode D2. Okay. Therefore, you can see here when the chopper is on, E naught is equal to 0, and when the chopper is off, and in that case diode D2 is conducting. When chopper is off, diode D2 in conduction mode, in that case E naught is equal to EDC. Okay, so when the chopper is off, the load current, that is I naught, has the direction opposite direction. Okay, and the average load voltage E naught is always positive, and output current, that is I naught, is negative. Okay, or simply you can say that in this case the power flows takes place from load to the source. So for the detailed explanation, you can read this. So why this is called as second quadrant chopper? Because output voltage is positive and output current is negative. That's why it is called as second quadrant chopper. So you can refer these waveforms. Okay. Now again, there is no need to go in detail explanation. This much explanation is enough, and the waveforms. Now we will go to the next, that is two quadrant or class C chopper. Now class C chopper is the combination of class A and class B. Okay, you can read this. So the switching from class A to class B configuration is satisfactory method for regenerative braking, but for some applications like machine tool drives, very smooth transition from driving to the braking is essential, and this required drive to provide the conducting type A and type B chopper in parallelly. So this is the configuration where chopper A or type A and type B are connected in parallel fashion. Okay, so here you can see this. This is chopper 1, chopper 2, diode 1, diode 2. And this is the output voltage and output current characteristic. Output voltage is positive and output current is positive or negative. So for simplicity, the same diagram is converted into a simple diagram: chopper 1, chopper 2, D1, D2, RL, and here EB, that is the voltage. So initially, when both the choppers are off, both the diodes D1 and D2 becomes also off, and therefore load is isolated from the supply. So at point P, this is the point P, chopper CH1 is triggered and it starts to conduct. The load current I naught is positive and the load receives power from the supply. Therefore, output voltage E naught will become EDC. And when the chopper 1 or the diode D2 conducts, at that time chopper 1 and diode D2 conducts. At point Q, means letter point, chopper 1 is turned off and inductor L forces to the load current to flow through the diode D1, okay, till the stored energy is equal to 0. Therefore, at that point D1 conducts, and at that point the gate signal goes to the chopper 2, and now uh, chopper 2 is, so here you can see this. In this case they have given the explanation in detail. So basically This particular step is continuous until CH2 is turned off and CH1 is turned on. So chopper 2 is now turned off. The energy of the inductance which we have discussed forces current through the diode D2 to the supply. The input current becomes negative. During this period, chopper 1 cannot conduct due to the reverse bias but comes into conduction when the input current reduces to 0, which provides the gate signal is available for chopper 1 and both the load and the input current becomes positive. Hence, it becomes clear at or the load voltage A naught is equal to 0 if chopper 2 or diode D1 conducts, and output voltage is equal to EDC if chopper 1 or diode D2 conducts. So therefore, if you take average of the output voltage, then the average output voltage or the average load voltage E naught is positive in both the conditions. However, if you see about the output current, that is the load current, though the load current have both the directions, that is the positive and negative. When it is positive, it is positive when chopper 1 is on or diode D1 conducts, and when it is negative if chopper 2 is on or D2 conducts or D2 is on. Okay, so this is about the class C. So this type of an configuration is used for both motoring or regenerative braking of DC motor. Okay, so these points, there is no need to go through these points. If you want, you can go, but as far as your final exam is concerned, there is no need to go through these points. Now we will switch to the 4 quadrant chopper, which is class E chopper or type E chopper. So this is very interesting to see. So 4 quadrant chopper system can be considered as the parallel combination of two type C choppers. In this chopper configuration with motor load, the sense of rotation can be reversed without reversing the polarity of excitation. So here we are going to use 4 choppers and 4 diodes. So here we can connect the motor, chopper 1, chopper 2, chopper 3, chopper 4, diode D1, D2, D3 and D4. So this is class E chopper or type E chopper. So you can see its output voltage, output current characteristics. So in simple manner, okay, by removing the motor over here. So this is the simple configuration for type E. Now we will see how it works. So when the choppers CH1 and CH4 are turned on, means chopper 1 and chopper 4 turned on at the same time and chopper 2 and chopper 3 turned on at the same time. So we will see when chopper 1 and chopper 4 are turned on simultaneously, current flows through the path EDC, chopper 1 load, chopper 4 EDC. Since both the E naught and I naught are positive, we get the first quadrant operation. When both the choppers are turned off, so load dissipates the energy through the path load T3, EDC, EDC positive, EDC negative and D2 and again load. In this case, E naught is negative but I naught is positive, which is the fourth quadrant operation. Now, as I said, chopper 2 and chopper 3 are turning on and off simultaneously. So when chopper 2 and chopper 3 are turned on, current flows through the path EDC plus, chopper 3 load, chopper 2 and EDC minus. Since both E naught and I naught are negative, we get the third quadrant operation. And when both the choppers are turned off, load dissipates the energy through the path, that is load D1, then EDC, then D2 and the load. In this case, what is happening? Output voltage is positive and output current is negative. Hence, this operation indicates which quadrant? Obviously, it is the second quadrant operation. So, here using 4 choppers and 4 diodes, we can have the circuit operation in 4 quadrants. So that's why this chopper is called as type E or 4 quadrant chopper. Okay, now all these next points are not there in your syllabus. Directly we are jumping on the last point of your syllabus, that is Jones chopper. So these are the two applications of the chopper. Jones chopper. Jones chopper, in this case, what you have to do, you have to prepare this diagram along with this waveforms. Jones chopper, only this much part. These equations, there is no design consideration not required, only this much part. Only till this point, Jones chopper is expected. And the next application is Morgan chopper. Again, these examples are not expected. There is no need to prepare. And the next application is Morgan chopper. This Morgan chopper is also what you have to prepare. This diagram you have to prepare and the waveforms. Let me show you the end point. So this is the end point. Okay, so these two applications of the chopper, that is the Jones chopper and Morgan's chopper. So these 2 points you can take for the self study. Okay, don't forget, these 2 points are very very important, Jones chopper and Morgan's chopper. Okay, so this part AC chopper is not included in your syllabus. So here we have discussed 100% or all the points from your syllabus for this chopper chapter. Okay, so today here we are going to stop. In next lecture we will start in inverter. Okay, so thank you so much, and we will meet in the next lecture. Thank you.